Here we go with our notes. Everybody should have notes out to this page. We're going to be flying around, writing in a bunch of stuff and actually crossing out a bunch of stuff. I'm going to give you this homework assignment. I need you to cross out the 4.3. I forgot to change that. We're going to change it to 205B. Okay? So we're going to do notes on this page, and we're going to have a paper homework assignment, 205B. Now, on your laptop, should have your laptop out. I need you to get to a new kind of homework assignment. So what you're going to do, go into your Google account and go to the waffle. Once you click on the waffle, I need you to go and search down for Easy Bridge. Easy Bridge. Okay, once you click on Easy Bridge, you might have to link it to your Google Classroom. You have a blue thing to click on, a blue line to click on. It won't look like this, it'll look something different. Okay, I'm gonna get Emma's computer here. Okay, but it'll look like this. Okay, and then you click on that, and it takes a little second. Takes a lot of time. And then it comes here and you pick a profile. Okay? And so I'm going to let you pick a different profile later. Pick your profile. And it comes in this way, and you should come here. And it might say link to Google Classroom. Go ahead and link to Google Classroom. You'll have to answer a few questions. So, yep, you are Emma. Hi. And you continue. Wow, that should be your screensaver right there. That looks good. We're going to select all and continue. You shouldn't have to do that every time, but you need to do that the first time. And we should come here, and you should see 4.5. This is your online homework assignment. It should be very similar to Alex. Okay? Thank you, Emma. You're wonderful. It should be very similar to Alex. Now, I need you to work on it. There's about 9 questions, 10 questions. I need you to work on that. And I really, really, really need a big feedback comparing this system to Alex. So I need everybody to do it. Okay? Work on it the best they can, but compare it to Alex later on. All right. Back to the notes. Let's get started. Ready to write? Ready to write in a hurry. Okay. We got 2 different words. We want to just have a working understanding of them. But basically, both of these things, in my mind, an easy way to remember them, they're both rules. They're both rules. Okay. When you see something as a theorem or something else as a postulate, that's just something that's true. Okay. So I like to say a theorem is a rule that has been proven. Enough said. Or can be proven. Okay? A theorem is something we have to prove. Technically, it is a conjecture. A theorem tends to go something like, if blah, 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 then blah, blah, blah. Okay? So if this happens, then we know that that is true. And if it is a theorem, then this statement, this conjecture statement, is proven to be true. A postulate is still a rule, but it is assumed true. Notice it is not proven. It is not proven. One of the most famous postulates is the segment addition postulate, and it kind of goes like this. I'm going to draw this out. Okay, you don't have to copy this, but if you have a line segment, right, and that line segment gets broken up into 2 pieces, the segment addition postulate says that if you take this length plus that length, then you end up with the entire length. No duh, right? That just seems obvious. If I measure this little amount and then that bigger amount and add it together, I'll get the whole thing. Well, that is a true statement that has never been proven. It's just assumed true because it seems so obvious. It's also never been disproven. So what's the point? If you see something that says theorem, then that means this is something that has been already proven true. We can trust it. If you see something that is in postulate, that means we are assuming that's true, but it seems so obvious that we can trust it. They're both rules. We just know they're true. Every theorem and postulate pretty much has an if-then form. So if this first part is true, we know the second part is true. In this case, here's the first part, if a point is on the perpendicular bisector of a segment, then, second part, it is equidistant from the segments. It's basically, we're gonna match things up. And so we want to really, I don't need to know this theorem unless I'm doing proofs so much. I need to know how to look at a picture and make things equal. So it's saying, hey, if I drew this line here, and that line splits this in half, bisect, and it's perpendicular, so if this vertical line splits this segment in half and is perpendicular, then I know these two things are equal. Now the converse flips that in half, and I'm going to paraphrase, okay? If equidistant, okay, if a point is equidistant from the endpoints of the segment, then perpendicular bisector, okay? So I'm not writing all the words. I'm not trying to do a thesis statement. I'm not going to be a lawyer. But you can see, kind of, sort of, I switched the two arguments. The first one says if a point is on the perpendicular bisector, then it is equidistant from the two sides. The second one, the converse, you just flip them around. If it's equidistant from two sides, then it's on the it just means this. It just means this. If you have a triangle, and this side are the same, then the line going down perpendicular, it will split that other segment in half. Or if the line going down splits the other segment in half, then it's going to be perpendicular. The whole goal of this is finding out what equals what. What equals what. Flip the page real quick. Let's just take a look at these top two. Now it says, what is the value of AD? I like, because sometimes it's hard to highlight AD. AD is right here. So what is the value of AD? Okay. Well, as I look at this, what am I seeing? I'm seeing that I have a triangle, two triangles, three triangles, and this line comes down and is perpendicular. So, okay, I got perpendicular. And I see that this side is split into two equal sides. So that tells me that these two sides should be equal. If I'm perpendicular and these two are equal, then this one and this one. So I just take 5, oh, that's a 6. 6x minus 10 equals 3x minus 2. And I'm going to go ahead and just solve that really quickly. Subtract that. 3x minus 10 is that. And then I'm missing something. This is a plus right here. That was a plus. Okay, so then I add the 10 over here, and then 3x is that, and then I divide. This should be pretty easy by now. And you get x is 4. And a lot of us want to stop there, and a lot of times that's where you need to stop. But the question said, what is the value of AD? And so we need to take a 4 and plug it into AD. 3 times 4 plus 2. 3 times 4 is 12. 12 plus 2 is 14. Okay, so this is important, but we wanted 14. But what's the goal? If we can see things equal, whatever, what equals what, use common sense. I don't need you to prove the theorem. To prove the theorem, I need you to pay attention to the detail of the statement. To do this, I need you to have a feel for the statement. I need you to be able to look at it and say, that equals that. Take a look at the second one. What's the value of FG? So FG is right here. Okay, what do I see? I see I got these two sides are equal, and I'm perpendicular to the other side. So if these two sides are equal and I'm perpendicular, then that means that has to be 6. I have to split it in half. So F stinking G is 6. By the way, what if I said EG? Well, EG is from one end to the other, so that would be 6 plus 6, or yeah, 12. Okay, but we wanted FG. So that's kind of the problems you're going to see. You're going to see problems like this, and all you have to really do is say, okay, what am I going to match it up with? Like here, if you look at this, some people will take 3x plus 2 and match it with 11, and that's going to be wrong. It doesn't make sense. So you got to think of what makes sense. Go back to the other note page. Go back. Angle bisector. Angle bisector. I don't even know what I put for the last class. I just thought it was nutso. I didn't even put anything. Okay? What is an angle bisector? A bisector cuts in half. This angle bisector is cutting or splitting an angle into two equal parts. Okay? And you can see the converse down here. If you want to know the regular theorem, just look at if and then. Here's if, and here's then. And switch. So the regular one is if a point is on the angle bisector, then that point is in the interior of an angle, and that point in the interior is equidistant from the sides. Ha! Who cares? Look at the picture. When I see arcs like this, little marks like that, that's telling me that those two little angles are equal. This top little, if we trace the letters A, B, X, this top angle right here is angle ABX. And if we trace the letters here, CBX, this bottom one is angle CBX. Now, it's okay to switch the letters around, XBC. It doesn't matter the direction. But B should be in the middle because that's where the angle part is. But it's just telling me, hey, with those marks, it's telling me that angle got split into two. So if this angle is 20, then that angle is 20. And the bigger angle of both of them is 40. So if I draw a line that splits that angle in two, then that means the distance from this point to one side is equal to the distance from this point to the other side. That's where I get 4 and 4. So we get angles that are equal and the side parts are equal. And the converse flips it. If this is the same distance to each side, then those angles are cut in half. Let's look at some actual problems that seem to fit this. So what do we get? Find KL. Okay, where is KL? K is here, KL is that. Find that. We want to find that right there. What do I see in the picture? I see right angle, right angle. Right angle usually is a signification that you're measuring distance. What about these little marks in here? This little mark, this little mark. That's telling me those two little teeny angles are equal to each other. Which means that this here, that line LJ, I'm going to put it like this. That line is an angle bisector. Because those two little marks says I got cut into equal parts. When you cut something in half, which half do you want? Shouldn't matter if it's cut in half. Both halves should be the same. So if I have an angle bisector, then that means this point to one side should equal that point to the other side. Seems logical. These two sides, 4x minus 11, equals 2x plus 3. Those two things should be equal. That's our goal. How can I figure out what two sides are equal? Subtract that. Add that. You with me? You following? You writing quick enough? You have to pause. Boom, 7. I'm done, right? No, what's the directions? Find KL. KL is 2x plus 3. So I got to plug that into KL. 2 times 7 plus 3. That's, what's 2 times 7? 14. 14 plus 3, 17. So there's my, this is important, but there's my answer. Sometimes all you need is x. Sometimes you got to plug it in. All right, this next one's a little wacko. I'll try to keep some of that on screen right there. All right, given, what is that m? M, that little m, this little m right here, when you're talking about angles, it simply means, quote, the measure of. And it's technical. It's like when you have a new Lego toy and they're all the Legos in a plastic bag, and the plastic bag says, warning, bag may cause choking. No duh. No one eats bags. Okay? So that simply means the measure of. So it's a technical little thing. I always skip it because I'm kind of lazy that way. So you don't have to pay attention to the m. It's not important. It is important technically, but for what we're going to do, you can skip it and still live. So given that angle BAD is 11x minus 18, and angle CAD is 4x plus 3, find angle BAC. All right, watch this. To figure out where angles are, trace the letters. BAD. B is here to A to D. Angle BAD is this angle right here, this little part. Coolness? Coolness. CAD, start at C, go to A, go to D. This, on this side, that's angle CAD. Find angle BAC. Okay, B to A. Oh, BAC is these two put together, yeah? Like if you put those two together, that would be BAC. So this little angle and that little angle and BAC. So what should we do? Well, I got right angles. I got 2 equal sides. If I have 2 equal sides, that means this point is the same distance. So that means this right here, this must be an angle bisector, because that point is the same distance to both, so it must cut that angle into 2 equal parts, meaning angle BAD should equal angle CAD. We got to be very careful with these problems. The 2 little angles are equal. Sometimes they give you 1 little angle and a big angle. And so we got to be careful how we do this. But go ahead and, subtract that. You get that. And then you kind of add that. And you get that. And then you divide by that. And you get that. Don't laugh at me. Now, I need BAC. Well, if I take X and plug it back into angle BAD, 11 times 3 minus 18, that's 33 minus 18, that's, I'm going to check it, I don't want to think, 15, okay? BAD is 15. That means this red angle is 15 degrees. But I just told you that this red angle here and this green angle there, I just told you they're equal. So that means they're both 15 degrees. If they're both 15 degrees, what is BAC? Yeah. So if BAD is 15, then angle BAD and angle BAD and angle CAD are equal, so that's 15 equals 15. Then angle BAC is equal to 15 plus 15, or 30 degrees. Woohoo! Throw a party. It's Layla's birthday. Oh, that was recorded. Bless you. So all these things, like there's these stupid, well, they're not stupid, they're really like super intelligent, but they're over our head theorems, right? But if we can kind of grasp the idea of the theorem is telling us that things are equal, and it should be relatively intuitive to match up what's equal to what. It should make sense. Well, that should be equal to that. And we just move on. Okay, now I'm going to move on to the next page. I'm going to talk about some different stuff. All right. Stuff I like, stuff I don't like. I kind of like median. At the bottom, I kind of like altitude. Centroid, okay. I don't care for the other two, but we'll talk about them. What is a median? Paraphrase. This right here is my median. It goes, each of these corners are called vertices, or a vertex. It goes from one of the vertices to the midpoint. Okay, I'm going to write that. Midpoint. How do I know it's midpoint? I'm saying these two are equal, so that has to be the middle. And then I'm going to put up here, this is a vertex. There are three of them. Any corner is a vertex. If I draw a line from one of the corners to the middle of the opposite side, that's called a median. So, segment from vertex to midpoint of opposite side of triangle. That's a median. If we got the visual, we don't need to write it. Okay? Concurrent lines. I can care less about you know what concurrent lines mean? They all cross at the same place. You have to write a definition, or can you just know that? If things are concurrent, they cross at the same place. Cool? Okay. Point of concurrency. That's the place they cross. So if that's a little L, I don't know what that is. Oh, that's a Z. That's a Z right there. So this point is the point of concurrency. That's the point where they all cross. So concurrent lines cross at the same point, and that point's called the point of concurrency. Woohoo! We're just excited now. Not. Now, that's a little bit good because how many medians could I draw? Say 3. I could draw one here like I did, but then what if I drew from this point across to this middle? That would be another. What if I drew from this point across to that middle? That would be a third. I could draw it from any of the corners. It would look like this. And this is called, this point here, I'm going to put a Q because that's a Q. This point here is called the centroid. It's the place where the medians all cross. Okay? Now, this is the big part here. This median got split up into 2 parts by that centroid. Yeah? Say yeah. Yeah. Here's the big part. The bigger part is 2/3. The smaller part is 1/3. Okay? And so, in my own words, not technical, not out of a book, the big part is 2 times the small part. One is 2/3, one is 1/3. So if the big part is 10, the small part is 5, because the big part is twice as big. If the small part, the red line, is, give me a number, 7, If a small part is 7, then the big part is 14. The big part is twice as big as the small part. What would the whole thing be? Well, add them together. Okay. Now we're gonna talk that. We're gonna do that in a little bit. But let's talk altitude real quick. Again, this is the altitude. How is it different than the median? It's perpendicular. Altitude is perpendicular. How many altitudes could I have? I could have 3 of them. I'm going from a vertex perpendicular to the opposite side. So segment from a vertex perpendicular. Now, here's a symbol for you. Memorize it. It's very important. Upside down, capital T. Upside down, capital T. That means perpendicular. Perpendicular to opposite side. The cool thing with the altitude, if you draw all 3 altitudes, one from each of the vertices, they all cross at the same place. They don't call it a centroid, they call it something else. But it's the same idea. All right. All right. This class rocks. So let's take a look here. This is kind of important. And if the video ends, we'll just jump into a new video and have 2 videos. Find KR if KP is 6. So I like to figure out where's KP. KP, right here.